All right, so the last thing that we were doing in our two-dimensional unit was looking at the area of a sector. And so the basic idea is just like when we did arc length, you've got a circle and you've learned for many years how to deal with the whole circle. The area of the whole circle is just pi r squared. And just as a little reminder, the perimeter of the whole circle, called the circumference, is 2 pi r. And I know it's really easy to mix these two formulas up because they've got the same three things in them. And so it's easy to think one, just get them mixed up in your head. One thing that I say over and over, it's kind of lame and silly, but the area is the square area. The area is measured in square units, so you know that pi r squared is your area formula. And then the other one, 2 pi r, that is your circumference because there's no square units there. So if I'm looking at the whole circle, then these are the formulas I use for the whole circle. But what if I only care about part of the circle? So let's pretend that's the center of the circle, and I'm really only looking at this slice of pizza right there. If I want to find the red area right here, then what I'm going to do is instead of looking at the full circle, I'm going to look at what angle is right there. And the textbook, sometimes it uses this letter as the angle. It's theta. I like to think of it as a little zero with a comb over. Or sometimes they'll use the letter alpha, which is like a little fish. Sometimes they'll use the letter x. It doesn't matter what letter you use. All we're saying is we've got a certain angle. Instead of looking at all 360 degrees of the circle, we're just looking at a certain angle. So if I want to find the area just of that sector area, what I do is I take my same pi r squared, but I look just at the fraction of the circle that is relevant. And so the fraction of the circle is your angle divided by 360 multiplied by pi r squared. So this right here is the fraction of a full circle. And then this right here is the area of a circle. So it gives you the sector area. This should feel very familiar to you because we recently talked about arc length. It has basically the same idea. Theta divided by 360 multiplied by 2 pi r. So as a quick example, if we have a problem like let's say we have a bike tire, and the bike tire is, let's say, 20 inches in diameter, and the spokes are, let's say, 30 degrees apart. And then we want to find the sector area. To find the sector area, what we would do is we would just do, I'm going to say sector area is 30 degrees divided by 360 times, just a second. And so we got the 30 over 360, and then we have pi times the radius squared. And you might wonder, wait, where did the 10 come from? I said the bike tire was 20 inches in diameter. So if you divide that by 2, that's how I got the radius. So just be careful. Make sure you're reading it carefully. And you can just type all that into your calculator, either on your phone or in the classroom. So just 30 divided by 360 times, if you need to get pi on your phone, you can just go times, turn it sideways, and then pi is kind of on the bottom there. And then times 10 squared. So you can just go times 10 times 10. And you end up with approximately 26.18. And that is measured in square inches because we had the squared inches right there. If I wanted to find the arc length, I would just use the arc length formula, and I would just say it's 30 divided by 360 times 2 times pi times 10. So let's just see what that comes out to be. 30 divided by 360 times 2 times pi times 10 comes out to be 5.24, and that's measured in inches. So there you go. Arc length and sector area are basically the same idea, just one is looking at area and one is looking at length. So please comment if there are any questions or let me know what else I can do to help.